Okay, so I will discuss about the response spectra method. Okay, the first thing is first you have to define all the beams, columns, slab, everything. Okay, once you define that, then go to the functions. Okay, then go to the response spectrum. Here you have to define add new function, right? So here I will just give it as RESP, response spectra. Okay, so that is how a response spectra, and damping by default as per IS Codal 0.5% damping, right? So then you have to just choose the zones. Okay, so wait, it is maybe American code. Okay, so I have to choose first Indian code, right? So Indian code choose. Okay, so add new function. So here I will call it as RESP. Okay, so then you have to choose here. I initially told you Sambhajinagar zone 2, right? 5% damping. So 0.1 importance factor, I told you 1.2 I have taken. Then soil type 2 and response reduction factor is 3. Okay, so then I have defined my response factor. Okay, so next after that I have to go to the define, go to the load cases, not load cases, go to the load patterns. Okay, so here you define response spectra in x direction. Okay, so this has to be a seismic. Okay, and as per codal provision, this one. So next one is add. I have not done add. Okay, so response spectra, then add new load. Next one is again y. Okay, so y seismic 1893 2000 add. Okay, so next it has been done. So EQX I will delete this. Let it be there. Okay, no issue. So what about load cases? It is there. Okay, let it be there. No issue. X and y. So then after that, what I have to do is I will just go to the define, then load combination, load cases. So here response spectra, modify. So here it is response spectra option you have to choose. Okay. See the mass source it has to show here. If it is not showing means your results will not come. So your mass source has to be defined. So there. So then again add. So now acceleration. See U1 means x direction. U2 is y direction. U3 is z direction. Rotation in x, rotation in y, rotation in z. Okay. So already I have defined my response spectra here. So x. So here the scale factor. So what is the scale factor is what? It is, you see, your SA by G is there, right? So where is that SA by G? Here it is. So SA by G. So it is scale factor is what? It is SA by G. Uh, so this SA by G is scale factor. So into gravity 9.81. So that is been defined in mm. So according to that you have to take it as 9810. Okay. So it is in mm the scale. Okay. So what is that? Is see here. What I have done is where is that this thing? Paint. Okay. Now SA by G. Okay. So into G. Okay. So now what I have done is this got cancelled, this got cancelled. Only I left with this SA value. So that is what I have incorporated here in the software as 9810. Okay. This is a scale factor. Add. Okay. Next is acceleration again in the y direction. U2. Okay. So then for that, so here I will not do. Here I will, okay. So this is, see, you go to the CQC method only. It will give you more accurate compared to all other things. Okay. So that is one. Okay. CQC. So here. So this is okay. So next is Y. Okay. Again modify. So this is Y. This is the response spectrum. So add new acceleration in terms of Y. U2 means Y. It is again response. So again it is 9810. Okay, so add. Okay, so now response spectra both in x and y direction. So after that, do the analysis. So you can see the, after that you can just see the, this is 3D view. Okay, so you can see the response spectra in x direction. Okay. So then this is your shear force and bending moment diagram. You can see this is M3. Okay, then if you want shear, okay, so this is what you can see, and the deformation you want to see this one. Okay, so and you want to see the results display, story response plot, and here what response spectra in x direction. Okay, so maximum story displacement, maximum story drift, maximum story shear. Okay, these are the three things what you can see here. Okay, you can generate the report also. Okay, so these are the three things. Then what you have to do is, the most important thing is in the code, that is they have told you is, uh, select the pattern. So response spectra in x direction I will take. Okay, and EQX in x direction. Okay, so then EQX and response spectra, let it be model is there, let it be there. Okay, so here what will happen is, EQX, right? So here it is 24. Hmm? Response spectra is 23. Okay. So what the code says is, the response spectra can never be less than the EQX. So he has mentioned here in the code. Here it is. 56 page number. See here what he has written is, see this base shear, what you calculate from the response spectra is the dynamic response spectra. Okay, so this is a static. Okay, so what he is telling you is, dynamic response spectra means VB dash bar on the top. So should never be less than this. If it is there, you have to recorrect that. So that is what is you have to do. Okay, so VB bar calculated using the fundamental time period. Okay, here he has written. Okay, when VB is less than VB bar, the force response quantities, for example, members story shear and base reaction shall be multiplied by VB bar by VB. So, आपको what you have to do is, you have to calculate that and multiply VB bar, this response spectra in x divided by EQX, that value into your response reduction factor. So again, what you have to do is, again you have to unpause it. Okay, so then again go to the define load cases, response spectra in x direction, modify, then here in the scale factor, that VB bar divided by VB, that you have to multiply here, and again redesign, so you will get the same value. So this is how we should know. So if you ask the display option show tables, so it will give you the result of that base shear. Okay, so this is how you need to calculate.